Good morning. Today I'm going to explain our topic in algorithms, that is performance analysis. What is performance analysis? An algorithm is said to be efficient and fast if it takes less time to execute and consumes less memory space at a runtime is called performance analysis. It is classified into two types: space complexity and time complexity. The space complexity of an algorithm is nothing but how much amount of memory required by an algorithm during the complete execution. That is called space complexity. There are three types of space while we are used in while executing the algorithms, that can be classified into three types: instruction space, data space, and environment. Instruction space is nothing but the actual program, that is the executable program, and data space is nothing but while executing an algorithm, what are all the constant and variable we are going to use, that is called a data space. And the environment is nothing but to store the environment information that is needed to resume the suspended space. This is it's all about space complexity. And second one is time complexity. The time complexity of an algorithm is the total amount of time which is required by an algorithm to complete its execution, that is called time complexity. Space complexity, can be classified into two types. First one is constant and second one is linear. Another type we can be called as a variable space complexity. Constant space complexity is nothing but while executing the algorithm, the memory which is allocated for that particular algorithm is never changed. It remains constant. That is called constant space complexity. But in linear, the amount of memory which is required for an algorithm to execute, it gets changed by passing an variables. That is called a linear space complexity. Here I'm giving the example for constant space complexity, that is the fixed amount of space for all the input values. How much time you are going to execute a particular code algorithm, that space which is allocated is never get changed. It remains constant. That is called constant space complexity. The example program what I am writing here is to calculate the area of square. What is the formula for square? Area of square is a square. So I am going to write a function name called square, and I am going to pass an argument, that is variable, as a. So it's going to calculate a square. So how much time I'm going to execute this particular part or particular algorithm, the memory which is required for storing this variable is never get changed. It remains constant. That is called a constant space complexity. Another one is space complexity. Space complexity, which I am already explained in the previous slide, it is nothing but the fixed part plus and variable part. Fixed part is nothing but the variables and constant we are going to use in our complete algorithm, that is called fixed part, and variable part is dependent on particular problem instance. Here what is the example I'm writing here is calculate the sum of two variables, and I'm going to store the result in another variable. So for that I'm using two variables A and B. I'm going to pass an input as 10 and 20 respectively, and I'm going to sum these two values and store in a constant another one variable, that is C. So total amount of memory I'm needed for while executing this particular part here is 3, because whenever I'm executing this particular part, the memory space which is required to allocate a memory space, it never gets changed. It remains constant. Here the same example which is used for a linear or variable space complexity. Here I am using an argument as a and n. A is nothing but I am used to calculate the value, but n is nothing but going to use pass the n variables. In this program, if I am pass the value n as a 1, this algorithm execute at least only one time. If suppose I'm going to pass the n value as a 10, this particular code will be executed into 10 times. So the memory space or space required for this particular execution of algorithm varies depend upon the n variables. Next one is time complexity. It is the amount of time needs to run to complete the execution of an algorithm. That is the compile time plus execution time. Here also classified into two types, constant and linear. Constant is nothing but what is the that is the amount of time execution for a particular algorithm. It takes only a constant time, it never gets changed. In this program I am going to sum two variables a and b. So how much time I am executing or run this algorithm, I am passing the values as a and a b, and it time complexity also remains constant, it never gets changed. But in linear time complexity, the input values are increased, the time complexity will also changes. Okay, here is the example. Here I am using the for loop and I am going to execute this for loop for a n number of times. So whenever I am passing the n values as different values, this particular algorithm I am executing, the time complexity will also change. It changed. Okay. So there are three types of kind of analysis. First one, three kinds of analysis: worst case, average case, and best case. What is meant by worst case? The maximum time of algorithm of any input of size n. So that is called worst case. Average case is expected time of algorithm to execute. That is called average case. Best case is nothing but minimum time required for an algorithm to execute. That is called best case. So the complexity refers to the rate at which the storage time grows as a function of the problem size. Next one is the analysis of the algorithm. What is the goal to analyze an algorithm is nothing but their running time and also the memory management. The running time of an algorithm depends on how long it takes a computer to run the lines of code of an algorithm. It depends on speed of computer, programming language, and compiler and translator. The examples are binary search and linear search. Asymptotic analysis, expressing the complexity in terms of its relationship, is known as the asymptotic analysis. It does not depend upon machine constant, does not require algorithm to be implemented, time taken by the program to prepare. Asymptotic notation is nothing but the mathematical way of representing the time complexity, that is called asymptotic notation. Asymptotic growth, the rate at which the function grows. The growth rate is the complexity of the function or the amount of resource it takes up to compute. The growth can be classified into three types: growing with the same rate, slower rate, and faster rate. There are three asymptotic notations are mostly used to represent time complexity of the algorithm: big O, big omega, theta, little o, and little omega. So what is big O notations? Asymptotic less than, that is the slower rate. It is the worst case time analysis because it is useful to calculate the maximum amount of time of execution, that is f of n less than or equal to c into g of n. The f of n and g of n to be a non-negative functions, and c is the constant values. So this is the graph which actually represent how it takes maximum amount to execute the algorithms. F of n is the actual expected time and C into G of n is the actual time for an algorithm to execute. This F of n equal to big O of G of n. So the big O represent worst case analysis. Second one is omega notations. Asymptotic greater than, that is the faster rate. It represents the lower bound of an algorithm runtime. How it can be represented in a formula means f of n greater than or equal to c into g of n. So c also constant, f of n and g of n is a non-negative integers. It is a lower bound and it is used for a best cases. Next one is omega notation. This notation can be used to represent in average time complexity. That is the what is the actual time expected by an user. For that case, omega notation is used. Okay. So this is the graphical representation of omega notation. This is f of n. This is the graphical representations of omega, that is f of n, and this is c into g of n. This is the time it can be executed in minimum time, that is minimum lower bound. This is the theta notations, that is C1, C2 both are constant variables, and G of n, G of n are non-negative integers, F of n. It may be increased or decreased, but it will be actually happen while executing the algorithm, that is the average time complexity. That is called F of n equal to theta of G of n. This is the example. Here I am taking the example f of n equal to 3n plus 2, c1 g of n less than or equal to f of n less than or equal to c2 into g of n. So f of n will be 2n plus 3. So constant c1 is 1 and constant c2 will be 4. So if I am executing this, the algorithms, it getting by n equal to greater than or equal to 2, the condition is satisfied. Other condition it will be false.